Hey guys, today is May the 30th and I'm going to do another LeetCode daily challenge. Oh, wait, let me just double check. Snakes and ladders. Okay, I've done this one before, but I guess it's a good review. Um, yeah, this is going to be interesting because I remember that this one was quite tricky when I did it. I kind of forget like what solution I did, but we'll see. You are given n by n integer matrix board where cells are labeled from 1 to n squared. Starting from the bottom left, yeah, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, so yeah, something like that. You start on square 1 of the board in each move. Yeah, choose a destination square next with label and range cur plus 1, min cur plus 6, n squared. The game ends when you reach n squared. Return the least number of dice rolls required to reach the square n squared. Just off the top, I'm thinking definitely some sort of BFS. Like to play this game, we have to simulate like the 6 possible rolls. So then that's going to be one number of dice rolls, and then we're going to simulate the next 6 possible rolls, and then that would be the second number of dice rolls required. And we're going to keep going until we hit 36, or we're going to hit n squared. But the way this board is formatted is kind of interesting, and I might need to think about it a bit. So what is the -1 mean? Oh, if it's a -1, then it's not a snake or a ladder. It's just like a regular point. Um, yeah, so I think there's nothing special about this being a 2D board. I kind of just want it to be an array that is flattened, and it's going to be of size 1, 2, 3, 4, 5, 6. So n is the length of the board. I want this to be of size n squared. So it will be size 36, which means we're going to do 0 to 35. But then maybe I could just do +1, and then we're just going to do it one index, just so that like cell 1 right here will actually correspond to the array 1, just so it's easier. That's why I have to offset it by 1. Okay, we're going to do that. So we just start at the end, so it'd be like for I in range n minus 1, minus 1, minus 1. Right, we're going backwards, like we're going bottom up, and then we are going to be, I guess, switching our direction every time. So maybe the direction can change from 1 to -1. So that's something I need to flip every single time, is flip the direction. What happens if the direction is 1? Then we just go to the right. So if dir is equal to 1, then let's explore to the right. Otherwise, explore to the left, right? We go from left to right if the dir is 1. If the direction is -1, we go from right to left. So explore, I could probably do a little bit better, from right to left. And then this one would be explore from left to right. So when we go from there, I guess we have an index, and that index will start at 1. So all we need to do is say the array at the index for j in range n, the array at index is equal to the board at ij. Yeah, that sounds about right. And then when we explore from, oh, sorry, this is left to right, and then this is exploring right to left. Right to left means we kind of go backwards, right? So for j in range n minus 1, minus 1, minus 1, array index is equal to board ij. Okay, and then make sure to change the direction every time. Oh, and then one thing that I forgot is the index needs to be upped every single like iteration, right? So we just do that. This is all of what I'm explaining right now. Oh, I forgot to turn this on. Cool. Everything I'm explaining is just the setup. So let me just print the array. Actually, for I in range 1 to n squared plus 1, let me print I, and let me print array at I. Yeah, so 1 would be negative 1, that's perfect. 2 maps to 15, 3 is negative 1, 4, 5, 6. All of that is all negative 1 until we hit 13. Once we hit, oh wait, how does the snakes work? Oh, I guess snake is like at 17 you'll be brought back to 13. That's what the snake is. It's not 13 moves to 17. Yeah, snakes kind of like hurt you. So that makes sense, right? 17, 13, that's what I'm looking for. I'm also looking for 14 to 35, and that's right here. 14 will bring you to 35. So what we essentially have done is created this like weird zigzag starting from bottom up, and they said it in this Bostrophodon style, and we're actually able to just put it in like a single array just so for like ease, so that it's easy to use. Okay, so I like what we have so far. Let's just go level by level, right? Let me see. Yeah, I think I feel like using BFS would just give us the shortest path to the answer. So that's what I'm gonna do. So I'm gonna say roles, maybe start with 0. I might be off by 1 in the future. We're gonna have a deck, and originally this deck is going to start at 1. Do we need a used? Maybe we want to use just to avoid repeats. Used is equal to false times n squared plus 1. q used at 1 is true. We already used it. And I think while q is, we're like ready to start the simulation of the game. So for every game, I think we roll 6-sided die, right? So is it rolls plus equal to 1? So we're about to roll right now, which means I want to roll everything in the queue. So for blank in range length of the queue, cur index is equal to q pop left. And so now we're all like, everything here is on row 1. So when we do q dot pop left, we're on row 1. Maybe we need to check like if this cur index is equal to the answer. If cur index is equal to the target, that's something I need. Target is n squared. If cur index is equal to target, just return rows, and then we're done. And then out of all this, I'm seeing return -1 if not possible, so I'm just gonna do that right here. Anyways, don't worry about that, we're gonna keep going. So now that we're in the current index, let's try to simulate 6 possible things. Let's simulate 6 things. So for I in range 7, I guess it's 1 to 6, which is 1, 7. Our next index is equal to cur index plus I. Check if it is a ladder or snake or out of bounds even, right? There's like 3 bad things. If the next index is greater than target, or so if it's greater than target, what do? We just kind of continue. If next index if the array at next index is not equal to -1, then we've reached a ladder or snake. We want to just move straight up into that position. If array next index is not -1, then our next index is equal to the array at next index. Can the ladder lead directly to the result? I think it can. Next index. So I just want to add this into our used. And then Q append next index, right? Okay. Otherwise, it is just a regular spot. So we just do use next index is equal to true, Q append next index. I think that's it. Let me run this, but I'm not sure. Okay. Okay, that's cool. I'm off by one, which is always like very lucky. This just means that when I return the roles, I need to be returning roles -1, or we could start roles at -1, or we could put roles to be updated after the for loop. So it's all preference. That's why off by one errors can be kind of tricky, but I was able to fix that pretty good. I'm not confident about this at all, but I do want to submit it. So let's go ahead and just submit. Okay, I don't know. I can't visualize a board like this, so I think what I'm going to do is just draw it out. Sorry, give me a second. So let's go ahead and draw out this example. 1, 1, -1, 1, 1, 1, -1, 1, 1. And oh, this is super interesting. What is this? So we obviously start at the bottom here, right? So we're on the first move. We could roll a 1, we can roll a 2, we can roll a 3, we can roll 4, we can roll a 5, or a 6. So let's just say we rolled a 1, it would go here. And then when we're at the 1, we see that we should move we see that it's a snake, and that it will actually bring us back to 1. We shouldn't go back to 1 if it's already in used. So that's something I need to check. Okay. If not used next index, then let's go ahead and say true and then append it. Okay, so let me use that test case. See if this works. Still not working. Let's see. Oh. Because it's in here. It's not going in here, oh, but this was a good move, I guess. But we're really looking about this one. So if array next is not equal to -1, next index is the array at the next index. If not used next index, then we just do this. Like that. Okay, let's submit that, see what happens. Oh, awesome. Okay, how long did that take? That took 20 minutes, and I've been a little bit rusty. Like, I didn't explain the code super well, but I'm happy that I was able to just like run through it, not do a lot of like code remodeling or makeover, just kind of like have an idea and slowly work it out. Honestly, that felt good.